Hi everyone, welcome back. In this video, we will discuss the top Java object-oriented programming interview questions and answers for freshers. Let's get started. What is OOP in Java? OOP stands for Object-Oriented Programming. It is a way of writing programs by using objects, where each object represents a real-world thing with its own data and behavior. In simple words, OOP helps us design software in the same way we think about real life. For example, a car is a real-world object. It has data like brand, color, speed and fuel level, and it has behavior like start, stop, accelerate and brake. In Java, we first create a class, and that class acts like a blueprint. Then we create objects from that class, and each object stores its own values while using the behavior defined in the class. The main benefit of OOP is that it makes code more organized, reusable, maintainable, and easy to understand. Instead of keeping data and methods separate, OOP keeps related data and behavior together, which is why it is widely used in real-world Java applications. Another important interview point is that OOP in Java is built around four core principles: encapsulation, inheritance, polymorphism, and abstraction. These principles help developers design flexible applications that are easier to extend, test, and maintain over time. So the best interview answer is this. OOP in Java is a programming approach where software is designed using classes and objects so that real-world entities can be modeled with data and behavior in an organized, reusable, and maintainable way. Next question. What is a class in Java? A class in Java is a blueprint or template used to create objects. It defines what kind of data an object will store and what kind of behavior that object will perform. We can understand this with a real-world example of a house blueprint. A blueprint is not the real house, but it defines the structure, rooms, design, and layout, and in the same way a class defines the structure of future objects. A class usually contains fields and methods. Fields represent the state or properties of an object, and methods represent the behavior or actions that objects created from that class can perform. For example, a student class can define fields like name, age, roll number, and course. It can also define methods like study, attend class, submit assignment, and write exam, which describe what a student object can do. One more important interview point is that a class itself does not hold real-world values until objects are created from it. That is why the class is called the design or blueprint, while the object is the actual instance that uses that design in memory. So the best interview answer is this. A class in Java is a blueprint that defines the data and behavior of objects, and it is used to create multiple objects of the same type with a common structure. Next question. What is an object in Java? An object in Java is an instance of a class. If a class is the blueprint, then the object is the actual real entity created from that blueprint and stored in memory. We can understand this with a real-world example of a car class. The class defines the common structure, but an actual red Toyota or black Honda is an object because it is a real instance with its own values. Every object has its own state and can use the behavior defined by the class. For example, one student object may store Amit, age 20, course Java, while another student object may store Ravi, age 22, course Spring Boot, even though both come from the same student class. Objects are important because they allow us to work with real data inside a program. We create objects when we want to actually use the design written in the class, store actual values, and call methods on those values. Another important interview point is that many objects can be created from the same class. They all follow the same structure defined by the class, but each object can hold different data in memory. So the best interview answer is this. An object in Java is a real instance of a class that stores actual data in memory and can perform the behavior defined by that class. Next question. What is the difference between a class and an object in Java? This is one of the most common beginner interview questions in Java OOP. The easiest and best way to explain it is by using the idea of blueprint versus real instance. A class is a design, template, or blueprint. It defines what kind of data and behavior objects of that type will have, but it is not the actual usable entity itself. An object is the actual instance created from the class. It exists in memory, stores real values, and can be used in the program to call methods and perform operations. A good real-world example is a mobile phone design and an actual phone device. The design defines features like brand, model, RAM, and storage, while each real phone is an object with its own actual values. Another important interview point is that one class can create many objects. For example, one employee class can create objects for Ramesh, Suresh, and Mahesh, where each object uses the same structure but stores different employee data. So the best interview answer is this. A class is a blueprint that defines structure and behavior, while an object is the real instance created from that class with actual values stored in memory. Next question. What are state and behavior in Java objects? In Java OOP, every object is commonly explained using state and behavior. This is a very important beginner concept because it helps us connect programming with real-world thinking. State means the data or properties of an object. In Java, state is usually stored in instance variables such as a student's name, age, roll number, or a bank account's account number and balance. Behavior means the actions an object can perform. In Java, behavior is defined using methods such as study, play, deposit, withdraw, and check balance. A very good real-world example is a bank account object. Its state can be account number, account holder name and balance, while its behavior can be deposit money, withdraw money, and check balance. Another important interview point is that state tells us what the object has, and behavior tells us what the object does. Together they help Java represent real-world entities clearly and make object design easy to understand. So the best interview answer is this. State is the data of an object, behavior is the action of an object, and together they help Java model real-world entities clearly through OOP. Next question. What are instance variables in Java? Instance variables are variables that belong to an object. They are declared inside a class but outside methods, constructors, and blocks, and every object gets its own copy of these variables. This means instance variables store the state of an object. For example, in a student class, instance variables can be name, age, roll number, and course, because every student object can have different values for these fields. A real-world example is a bank account class. If we create two bank account objects, both objects may use the same class, but one object can have account holder Ramesh with one balance, and another object can have account holder Suresh with a different balance. Another important interview point is that instance variables are accessed through objects. That is why they represent object-specific data and are usually initialized using constructors or updated through instance methods. So the best interview answer is this. Instance variables in Java are object-level variables that store the state of each object separately. So every object created from the same class can hold different values. Next question. What are local variables in Java? Local variables are variables declared inside a method, constructor, or block. They are created when that method or block starts execution, and they are destroyed when the execution ends. This means local variables are used only for temporary work inside a method. For example, inside a method that calculates total marks, we may create a local variable called sum or average just to perform that calculation. A real-world example is a method that calculates the discounted price of a product. Inside that method, variables like discount amount or final price may be local variables because they are needed only while the calculation is happening. Another important interview point is that local variables do not get default values automatically. They must be initialized before use, otherwise Java gives a compile time error because local variables exist only within their method or block scope. So the best interview answer is this. Local variables in Java are temporary variables declared inside methods, constructors or blocks, and they are available only within that limited scope during execution. Next question, what is the difference between instance variables and local variables in Java? This is a very common beginner interview question because both store data, but they are used in different places and for different purposes. The simplest way to explain it is by comparing scope, lifetime, and purpose. Instance variables are declared inside a class but outside methods, and they belong to the object. They are used to store the long-term state of the object, and they remain available as long as the object exists in memory. Local variables are declared inside methods, constructors, or blocks, and they exist only during that execution. They are used for temporary calculations or short-term processing, and they disappear when the method or block finishes. A real-world example is a bank account object. Its account number and balance can be instance variables because they belong to the account itself, while a temporary withdraw amount inside the withdraw method can be a local variable because it is needed only during that method execution. Another important interview point is that instance variables get default values, but local variables do not. That is why local variables must always be initialized before use, while instance variables can be used with their default values if nothing is assigned explicitly. So the best interview answer is this. Instance variables belong to objects and store object state for as long as the object exists, while local variables belong to methods or blocks and are used only temporarily during execution. Next question. What is a constructor in Java? A constructor in Java is a special member of a class used to initialize objects. It is called automatically when an object is created, and its main purpose is to assign initial values to the object's fields. A constructor has the same name as the class, and it does not have a return type, not even void. This is one of the easiest ways to identify a constructor in Java interviews. A real-world example is creating a student object. When we create a new student, we may want to initialize values like name, age, and course immediately, and the constructor helps us do that at the time of object creation itself. Another important interview point is that constructors improve object creation by making sure objects start in a valid state. Instead of creating an object first and assigning every value later, we can use constructors to provide the required data immediately and keep the code cleaner. So the best interview answer is this. A constructor in Java is a special class member that runs automatically when an object is created and is mainly used to initialize the object's state. Next question. What is the difference between a default constructor and a parameterized constructor in Java? This is a very common beginner interview question because both are constructors, but they initialize objects in different ways. The easiest way to explain the difference is by checking whether values are passed during object creation or not. A default constructor is a constructor with no parameters. It is used when we want to create an object without passing initial values directly, and then the object may use default values or values assigned inside the constructor body. A parameterized constructor is a constructor that accepts parameters. It is used when we want to provide specific values at the time of object creation. such as a student's name, age, and course, or a car's brand and color. A real-world example is a bank account class. A default constructor may create an account with some initial default setup, while a parameterized constructor can create an account directly with account holder name and opening balance, which makes object creation more flexible and meaningful. Another important interview point is that if we define any constructor ourselves, Java does not automatically provide its own default, no argument constructor. That is why developers often write constructors carefully based on how objects should be created in the application. So the best interview answer is this. A default constructor creates an object without requiring input values, while a parameterized constructor creates an object using values passed at the time of creation for better control over initialization. Next question. What is method overloading in Java? Method overloading means defining multiple methods in the same class with the same method name but with different parameter list. This is a very common beginner interview question because it helps explain compile time flexibility in Java. The difference between overloaded methods can be based on the number of parameters, the type of parameters, or the order of parameters. But only changing the return type is not enough because Java identifies overloaded methods mainly by their parameter list. A real-world example is a calculator class. One method can add 2 integers, another can add 3 integers, and another can add 2 decimal numbers, while all of them can still use the same method, name like add. The main benefit of method overloading is readability and convenience. Instead of giving different names for similar operations, we can use one logical method name and let Java choose the correct version based on the arguments passed. Another important interview point is that method overloading is an example of compile time polymorphism. That means the method to call is decided by the compiler based on the method signature during compilation. So the best interview answer is this. Method overloading in Java means defining multiple methods with the same name but different parameter lists in the same class, which improves flexibility, readability, and supports compile time polymorphism. Next question. What is method overriding in Java? Method overriding happens when a child class provides its own implementation of a method that is already defined in the parent class. This is one of the most important OOP interview questions because it is directly connected to inheritance and runtime polymorphism. For method overriding to happen, the child class method must have the same name, same parameters, and a compatible return type as the parent method. In simple words, the child class is redefining inherited behavior in its own way. A real-world example is an animal class with a method like soundParents. A dog class can override that method to return barking behavior, and a cat class can override it to return meowing behavior, even though both share the same method name. The main benefit of method overriding is specialization. The parent class defines common behavior, and child classes customize that behavior according to their own requirements, which makes the design more flexible. Another important interview point is that method overriding is an example of runtime polymorphism. That means the actual method that runs is decided at runtime based on the type of the object, not just the reference type. So the best interview answer is this. Method overriding in Java means redefining a parent class method in a child class with the same signature so that the child class can provide its own specific behavior and support runtime polymorphism. Next question. What is inheritance in Java? Inheritance is an OOP concept in which one class acquires the properties and behavior of another class. This is a very frequently asked interview question because inheritance is one of the core pillars of object-oriented programming. The existing class is called the parent class, superclass or base class, and the new class is called the child class, subclass or derived class. The child class can reuse fields and methods from the parent class instead of rewriting the same code again. A real-world example is a vehicle class. A car class and a bike class can inherit common properties like brand and speed, and common methods like start and stop, while also having their own specific features. The main benefit of inheritance is code reuse and hierarchy building. It allows developers to write common logic once in the parent class and then extend or customize it in child classes, which improves maintainability and reduces duplication. Another important interview point is that Java supports single inheritance with classes and achieves multiple type behavior using interfaces. This keeps inheritance simpler and avoids some of the ambiguity problems that can happen in multiple class inheritance. So the best interview answer is this. Inheritance in Java is the mechanism through which a child class reuses and extends the fields and methods of a parent class, which improves code reuse, maintainability, and hierarchical design. Next question. What is encapsulation in Java? Encapsulation means wrapping data and the methods that operate on that data together inside a single unit, usually a class. It is also used to control access to internal object data so that the object remains safe and well managed. In Java, encapsulation is usually achieved by declaring fields as private and providing access through public getter and setter methods. This way, the internal data is not directly exposed to the outside world, and access can be controlled through methods. A real-world example is a bank account class. The balance should not be changed directly from outside the class, so we keep it private and use methods like deposit, withdraw, and get balance to manage it safely. The main benefit of encapsulation is data hiding and better control. It protects objects from invalid updates, improves maintainability, and makes the code easier to test and manage. Another important interview point is that encapsulation helps us enforce business rules inside methods. For example, we can prevent a negative deposit or invalid withdrawal because all updates go through controlled methods instead of direct field access. Next question. What is abstraction in Java? Abstraction means showing only the essential features of an object and hiding the internal implementation details. This is an important beginner interview question because abstraction helps explain how Java manages complexity in large applications. In simple words, abstraction focuses on what an object does, not on how it does it internally. For example, when we drive a car, we use the steering, brake, and accelerator, but we do not need to know every internal engine detail to use it. In Java, abstraction is mainly achieved using abstract classes and interfaces. These allow developers to define common behavior contracts while leaving detailed implementation to child classes or implementing classes. A real-world example is a payment system. The common operation may be pay, but the internal implementation can be different for credit card payment, UPI payment, or net banking payment, while the user only sees the common action. The main benefit of abstraction is reduced complexity and better design flexibility. It helps developers build clean architectures, separate interface from implementation, and make code easier to extend and maintain. So the best interview answer is this. Abstraction in Java means exposing only the essential behavior of an object while hiding internal implementation details, and it is commonly achieved using abstract classes and interfaces to reduce complexity and improve design flexibility. Next question. What is polymorphism in Java? Polymorphism means one thing can take many forms. In Java, it means the same method name or interface can behave differently depending on the object that is using it. In simple words, polymorphism allows us to write common code and still get different behavior from different classes. For example, an animal class may have a method called sound, but a dog can give barking sound and a cat can give meowing sound. Java mainly supports two types of polymorphism, compile-time polymorphism and runtime polymorphism. Compile-time polymorphism is usually achieved through method overloading, and runtime polymorphism is achieved through method overriding. A real-world example is a payment system. The same method like pay can be used, but one object may process payment using a credit card, another using UPI, and another using net banking, so the behavior changes based on the actual object. The main benefit of polymorphism is flexibility and extensibility. It allows developers to write generic and reusable code while letting different classes provide their own implementation. So the best interview answer is this. Polymorphism in Java means the same method, interface, or reference can show different behavior depending on the actual object, which makes code more flexible, reusable, and easier to extend. Next question. What is the difference between compile-time polymorphism and runtime polymorphism in Java? This is a very common OOP interview question because both are forms of polymorphism, but they work at different stages. The easiest way to explain them is by checking when the method call is decided. Compile-time polymorphism is resolved by the compiler during compilation. In Java, it is mainly achieved through method overloading, where multiple methods have the same name but different parameter lists, and the compiler decides which method to call based on the arguments. Runtime polymorphism is resolved during program execution. In Java, it is achieved through the method overriding, where a parent reference can point to a child object, and the method that runs is decided at runtime based on the actual object type. A real-world example is a notification system. In overloading, we may have different versions of send with different parameters, but in overriding, an email notification and SMS notification can both provide their own version of the same send method. The main difference is that compile-time polymorphism gives early binding, while runtime polymorphism gives late binding. This means one is decided before the program runs and the other is decided while the program is running. So the best interview answer is this. Compile-time polymorphism is achieved by method overloading and is resolved by the compiler, while runtime polymorphism is achieved by method overriding and is resolved during execution based on the actual object. Next question. What is this keyword in Java? This keyword in Java is a reference to the current object. It is used inside instance methods and constructors to refer to the object whose method or constructor is currently running. One common use of this is to distinguish instance variables from local variables or constructor parameters with the same name. For example, if a constructor parameter is called name and the instance variable is also called name, then this .name refers to the instance variable of the current object. Another important use of this is calling one constructor from another constructor in the same class using this parens. This is called constructor chaining, and it helps avoid duplicate initialization code inside the class. A real-world example is a student class. When we create a student object with values like name, age, and course, this keyword helps assign those values to the current student object correctly. The main benefit of this is clarity and correctness. It makes it clear that we are talking about the current object, which improves readability and avoids confusion in object initialization and method logic. So the best interview answer is this. This keyword in Java refers to the current object, and it is mainly used to access current object members, resolve naming conflicts, and perform constructor chaining within the same class. Next question. What is a super keyword in Java? The super keyword in Java is a reference to the parent class object part inside a child class. It is mainly used when a child class wants to access members of its parent class. One common use of super is to access parent class variables or methods when the child class has members with the same name. This helps remove ambiguity and makes it clear that the parent version is being used. Another very important use of super is calling the parent class constructor using super parents. This is especially useful when the parent class has important initialization logic that should run before the child class adds its own specific setup. A real-world example is a vehicle class and a car class. The vehicle class may initialize common properties like brand and speed, and the car class can call super first to initialize that parent part before adding features like fuel type or number of doors. The main benefit of super is that it helps reuse parent class logic properly. It supports cleaner inheritance design, avoids code duplication, and makes parent-child relationships easier to manage in Java programs. So the best interview answer is this. The super keyword in Java refers to the parent class and is used to access parent variables, parent methods, and parent constructors from a child class, especially in inheritance-based design. Next question. What is the difference between this and super in Java? This is a very common beginner interview question because both this and super are special references, but they point to different levels in an inheritance-based program. The easiest way to explain the difference is by remembering current object versus parent class. This keyword refers to the current object. It is used to access the current object's variables, methods, and constructors inside the same class. The super keyword refers to the parent class part of the current object. It is used to access parent class variables, parent class methods, and parent class constructors from a child class. A real-world example is an employee class and a manager class. Inside manager, this .name may refer to the current manager object's field, while super.name may refer to the inherited parent class field if both levels use similar member names. Another important interview point is constructor usage. This is used to call another constructor in the same class, while super is used to call the parent class constructor. So the best interview answer is this. This refers to the current object, while super refers to the parent class part of the current object, and both are used to access members and constructors at different inheritance levels. Next question. What are access modifiers in Java? Access modifiers in Java are keywords used to control the visibility and accessibility of classes, variables, methods, and constructors. They decide from where a member can be accessed, which is very important for object-oriented design and encapsulation. Java mainly provides 4 access levels: private, default, protected, and public. These modifiers help developers hide internal details, expose only required members, and protect data from unnecessary direct access. A private member can be accessed only inside the same class. A default member can be accessed only within the same package. A protected member can be accessed within the same package and also through inheritance in another package, and a public member can be accessed from anywhere. A real-world example is a bank account class. The balance field is usually kept private, so it cannot be changed directly from outside, while methods like deposit, withdraw, and get balance may be public, so users can interact with the account safely. The main benefit of access modifiers is security, maintainability, and better design control. They help us decide what should be hidden, what should be shared within a package, and what should be available to the outside world. So the best interview answer is this. Access modifiers in Java control the visibility of classes and members, and they help implement encapsulation by deciding whether a member should be private, package level, protected, or public. Next question. What is a static variable in Java? A static variable in Java is a variable that belongs to the class itself, not to individual objects. That means only one copy of the static variable exists and all objects of that class share the same value. This is different from instance variables where every object gets its own separate copy. A static variable is created when the class is loaded into memory and it remains associated with the class rather than any one object. A real-world example is a company name in an employee class. All employee objects may have different names, salaries, and IDs, but the company name is common for all of them, so it makes sense to store it as a static variable. Another important interview point is that static variables are usually accessed using the class name, not through objects. This makes it clear that the variable belongs to the class level and is shared by all instances. The main benefit of static variables is that they are useful for shared data, counters, configuration constants, and class level state. They save memory when the same value does not need to be stored separately in every object. So the best interview answer is this. A static variable in Java belongs to the class, not to objects, so only one shared copy exists for all instances of that class. Next question. What is a static method in Java? A static method in Java is a method that belongs to the class, not to an object. It can be called directly using the class name without creating an object of that class. Because a static method belongs to the class level, it can directly access only static variables and other static methods. It cannot directly access instance variables or instance methods because those belong to specific objects and a static method does not have any current object reference. A real-world example is a utility class like a calculator helper. Methods such as add, subtract, or square may be static because they perform general work and do not depend on any object-specific state. Another important interview point is that the main method in Java is also static. That is because the JVM must be able to call it without creating an object first when the program starts. The main benefit of static methods is that they are useful for common utility operations, factory methods, and class level behavior. They improve convenience when the logic does not depend on instance-specific data. So the best interview answer is this. A static method in Java belongs to the class and can be called without creating an object, which makes it suitable for utility logic and class level behavior. Next question. What is the difference between static and non-static members in Java? This is a very common beginner interview question because Java classes often contain both static and non-static members. The easiest way to explain the difference is by checking whether the member belongs to the class or to the object. Static members belong to the class itself. They are shared by all objects created when the class is loaded and are usually accessed using the class name. Non-static members, also called instance members, belong to individual objects. Each object gets its own copy of instance variables, and instance methods usually work with the specific data of that object. A real-world example is an employee class. The company name can be static because it is shared by all employees, while employee name and salary should be non-static because each employee has different values. Another important interview point is access. A static method cannot directly access non-static members because non-static members require an object, but a non-static method can access both static and non-static members because it works through an object reference. So the best interview answer is this. Static members belong to the class and are shared by all objects, while non-static members belong to individual objects and store or operate on object-specific state. Next question. What is an abstract class in Java? An abstract class in Java is a class that is declared using the abstract keyword. It is used as a base class when we want to define common structure and behavior, but we do not want objects to be created directly from that class. An abstract class can contain abstract methods and non-abstract methods. Abstract methods do not have a body and must be implemented by child classes, while non-abstract methods already contain code and can be directly reused. A real-world example is a vehicle class. All vehicles may have common fields like brand and methods like start, but the actual implementation of fuel type or move can differ for car, bike or truck, so the base class can be abstract. An important interview point is that we use an abstract class when classes are closely related and should share some common code. It helps avoid duplication and provides a partial design that child classes can complete with their own specific implementation. So the best interview answer is this. An abstract class in Java is a partially complete class that cannot be instantiated directly and is used to provide common fields, methods, and abstract behavior for its child classes. Next question. What is an interface in Java? An interface in Java is a reference type used to define a contract that classes must follow. It tells what methods a class should provide, but not the full implementation details in the traditional sense. In simple words, an interface focuses on what should be done, not on how it is done. A class that implements the interface must provide the implementation of the required abstract methods. A real-world example is a payment interface with a method like pay. Different classes such as credit card payment, UPI payment, and net banking payment can implement that interface and provide their own version of payment processing. An important interview point is that interfaces support abstraction, loose coupling, and multiple inheritance of type. They help Java applications become more flexible because one interface can be implemented by many different classes. So the best interview answer is this. An interface in Java is a contract that defines what methods a class must provide, and it is widely used to achieve abstraction, flexibility, and loose coupling in object-oriented design. What is the difference between a class and an interface in Java? A class in Java is used to create objects and can contain fields, constructors, and fully implemented methods. An interface is mainly used to define a contract that implementing classes must follow. A class represents a complete or partially complete object design. An interface represents common behavior that can be shared across different classes, even when those classes do not belong to the same class hierarchy. A class can be instantiated if it is not abstract, but an interface cannot be instantiated directly. A class uses extends for inheritance and implements for interfaces, while a class can implement multiple interfaces but cannot extend multiple classes. A real-world example is a car class and a drivable interface. The car class is a real object design with fields like brand and speed, while the drivable interface simply defines a behavior contract like drive that many classes can implement. An important interview point is usage. We use a class when we want to create real objects with state and behavior, and we use an interface when we want to define a common capability or contract for multiple classes. So the best interview answer is this. A class is used to define and create objects with state and behavior, while an interface is used to define a contract of behavior that different classes can implement.